What's poppin', dogs? Mr. Allen here with a problem involving tangents of circles. So we got AC, this segment right here, is tangent to circle B at point D. So that means it just touches only at that single point. It's just resting on the circle. That's what it means to be tangent, okay? Now it says AD is 6, AB is 10, and DC is 15. Find BC, the area of the circle, and the circumference of the circle. Okay. So we got a lot going on here, right? We got to find some segment lengths, and it sounds like we also need to find our radius if we're going to be able to calculate the area of the circle and the circumference of the circle. So let's start by labeling this thing up. We got 6 right here, we've got 10 right here, and I've got 15 for this guy over here. Well, I don't even have a radius. Well, I guess I have a radius right here, right? But that's not 10 because it includes that little part right there as well, you know? So perhaps I need to draw a radius in. And I'm going to do so between points B and D. And there's a reason why, all right? Now, since since AC is tangent at D, that means that a radius drawn to that point of tangency is then perpendicular to that segment. So now I get a right angle. And with a right angle, I have right triangles here, and I can use Pythag if I know two sides, which I do, to figure the situation out. Now, this is a 6, 8, 10 triangle here. It's a Pythagorean triple. That's a 3, 4, 5 triple that has been doubled. So it becomes 6, 8, and 10. If you didn't know that, it's okay. You can always just do a squared plus b squared equals c squared. In this case, it would be 6 squared plus b squared equals 10 squared. And you could solve from there, okay? So either way you slice it, you can figure out that length. Now, I can actually also get BC right now as it sits because I have two sides of a right triangle. You could either set up 8 squared plus 15 squared equals c squared, or you can know that it's an 8, 15, 17 triangle. Boom. Pythagorean triple again. These come up quite a bit. It's not always going to be a Pythagorean triple. A lot of times when I make these problems, I make them Pythagorean triple, so the numbers are really nice to work with, and you're just really thinking more about the properties of those circles. All right, so I've got BC. We already know BC. I'll put that up here. BC equals 17. So that one's done. Then we have the area of the circle that we need, and we have the circumference of the circle that we need. Okay. So now what? Let's see here. Well, I have my radius, right? So that means I could probably find my area and circumference pretty easily. So my area of this thing, area of the circle is equal to pi times my radius of 8 squared. So that's just going to be 64 pi units squared. So 64 pi units squared. If I had inches or whatever, it'd be inches squared because it's an area, right? A length, which would be our circumference, would just be normal units. Now, for my circumference, I'll go ahead and use this like neon yellow color. We got circumference equals, and that's just 2 pi r. So 2 times pi times my radius of 8 that I found. So we get 16 pi units. 16 pi units. Boom. That's it, man. That's dope. So main thing to remember here is that if we are tangent to the circle, then a radius drawn to that point of tangency gives us a right angle, which is super duper powerful because then you can set up right triangles. You could even possibly get tricky with it if I gave you like an angle and you had to figure things out. So, the sky's the limit with these things because circles are awesome. But that's about it for this one. Hope you guys liked it. Keep on watching some circle videos because the fun is endless, all right? Have a great day.